mocking, dependency injection, TDD. Shout out to Ryan. I work at Pivotal. We do pair programming. So yeah, like in the spirit of that, I'm going to be doing a little bit of live coding later in the talk. So interrupt me, ask me why I'm writing something, ask me why this slide looks funny, something like that. We can have a conversation. I'm going to be presenting like the views that we tend to follow here at Pivotal in terms of how to write code. But I would love to hear from other people during and after the talk about what parts of that they like and dislike, what you use when you're writing code. Speaking of which, who here like writes code regularly? Okay, keep your hand up if you're writing Go regularly. Awesome. If you like test drive your Go code. Okay, cool. That's good to know. So we do that at Pivotal. I work on the CloudFoundry team. It's actually, there's like 40 teams that work on CloudFoundry across the world. The teams here in Los Angeles, there's a team that does like there's a team that builds the basically all of Pivotal's version of CloudFoundry from open source and proprietary components. I should say what this is. CloudFoundry is a platform as a service. It's, if you've ever used Heroku, it's a lot like that, but it's open source, and you can install it on your own data center. And so I get paid to work on open source software all day, which is pretty awesome. The team I'm on is working on container-to-container networking. So if you ever use Docker, it's like that, making those things talk to one another. We're just in the beginning stages of that project. So you can ask me about that at the end, too. Before I started at Pivotal, which was like a year and a few months ago, I was working on 3D printers for kids. That was fun. It was a startup. It totally went under, but I got to write like iPad apps and help work on firmware for those beautiful machines. So yeah, before that I was like doing math and neuroscience and some other stuff like that. The plan for tonight, I'm going to talk about test driving, BDD, what those are, why we do it a little bit. I'm not going to make you drink too much Kool-Aid, but I'll talk a little bit about what we do at Pivotal. And then I'm going to go through and like live code an example of a web server, test driving it, and just sort of walk you through the process we use when we're writing code. So people who have like on my team here in CloudFoundry at Pivotal they're going to be pretty familiar with this stuff. But I hope other people find this interesting. And then at the end, I'm going to talk about how to be a good citizen in a world where people are writing code like this. Even if you yourself don't test drive or don't do mocking or don't do call-based mocks, there are things you can do to make it a lot easier for other people to reuse your code. So I'll go through an example talking about that. And then I hope there's some time for conversation at the end. Any questions before I get started? Cool. So yeah, what and why about TDD and BDD? So test-driven development, this is what we do. We write the test first before we do anything else. We check that it fails in the right way. You can write a test and it might not work and it might fail and it might not tell you anything interesting. You might have to do some work to make sure that it's failing in the way that you expect it to be failing because the production code isn't there yet. Then you write some production code, the smallest amount that you can, to make that test pass. And you repeat this process. And at some point, you refactor, you clean things up, you get rid of cruft, you move things around. But this is the process that we follow when we're doing test-driven development. Now, behavior-driven development is sort of a style of this. It involves using English descriptions of tests. This really helps us like move from specifications for the software into what the tests actually require the software to do. And the idea is that these English descriptions should be totally understandable to the product manager or someone else who's not technical. So an example in Go looks kind of like this. And the wonderful thing here is that if you're not technical, you can just look at this and it means something to you. And it's up to us, the engineers, to verify that these English sentences actually map into the actual requirements of the code. But this is what it looks like when we're test driving. So, any questions there before I keep going? Cool. Yeah, we're going to like write a web server. It's going to be a very small bit of it, but we're going to start with that. So let's imagine we need to write an app that counts how many lines of code are in a source code repo. I don't know why you'd ever want to do this, but let's imagine you want to do this. So you can curl a web server at /lines, and then the path to the source code. where that lives. And you should get back some JSON that tells you how many lines of source code are there. So we're going to try to work on this. And this is going to be the approach. We're going to follow the TDD process, and we're going to go outside in. So the outside is writing a system test. This is sometimes an acceptance test, depending on how big your system is. Maybe there are different layers of this. And we're going to write a test, and we're going to watch it fail, because we haven't actually built anything yet. And then we're going to figure out what the right unit is that we need to build, and we're going to write a unit test for that. And at this point, we'll get to see dependency injection and interfaces in Go. And because we're unit testing, we're going to mock out those dependencies. We're going to watch that unit test fail, and then we're going to write the real code, make it pass. And at this point, I'm going to stop live coding and just say, we'll fast forward to the finished thing, because it's actually going to take a little while to get all the way down here. But at the end, we'll get to see the system test pass, and I'll give you a little bit of a tour of like a couple different ways that we can do mocking and tests with mocks in a system that has a couple different components in it. All right, so this blank slide means I'm going to start doing live coding. All right, here is a commented out system test. So we're writing right now this test that says it responds to a slash get with a hello message. So I'm going to uncomment out some lines. We're making up the URL to hit, and we're going to make this get request against this. Now, if you don't use the Go testing framework that we use here at Pivotal, it's called Ginkgo and GoMega. This might look a little weird, but this should look kind of like maybe RSpec if you've done Ruby before. We expect not to have an error not to have occurred on this get request. This is some cleanup right here to make sure that we don't leak things. But we're going to expect that the status code that comes back from that get request is a status OK. We're going to read the response body that comes back, and then we're going to expect that we get 42 lines back. Now I should say that the spec is not right. So it responds to a get with a line count. And let's just fast forward straight to lines and then some Go path. All right, so that's a test. You know what? Because this is a system test, I want to actually have it look at my real system and look at real source code that's on there. So how's the text size on this? Could be a little bigger. I'm going to like CD into my real Go path and go find something and count its lines and stick that into my test. So I'm going to go to my Go path, and I think there's something on here, like a protocol buffers thing. Great, okay. Let's count how many lines of code are in here. Who knows how to do this in like Unix and shell? -L, okay. Okay, right, so if I want to count every line of code, I'm going to do like find dot, and then like the name is going to be star.go. Yep, xargs, wc-l. Okay, cool. 26,071 lines of code. Let's grab that. Come back over here. We'll put that down at the end, and then we'll put in the correct path here, right? So GitHub, it was Golang protobuf. Okay. Let's see if this fails in the right way. I'm going to use this Ginkgo test runner. Uh-oh, there's nothing to run. All right. Unexpected end of JSON input. This is coming back from the server. I haven't shown you the magic of actually like booting the server. That's not especially interesting. Let's go over here. Okay, here is a empty web server in Go. It responds to slash with nothing. It doesn't print anything out at all. Let's make it print something out just to prove that we're kind of on the right track. We're not unit testing right now, right? We're just gonna like make it work to make sure everything kind of looks right. So on this response writer, I'm going to write some bytes and give it like an empty JSON object. Cool, okay, it expected to get lines back and it just got an empty JSON object. So now we're gonna like backtrack and actually like unit test drive the handler itself. Everyone with me on this so far? Any questions? Yeah. It's like kind of trippy, isn't it, right? Yeah, this is a Vim config of a San Francisco CloudFoundry guy. I think it's nice because it helps me see which pairs of parentheses and stuff. Oh, you want it? Okay, you want it, you should go to github.com, Luan, Vim files or something like that. Look up Luan on GitHub, and it's, there we go, awesome. Okay. So let's do some unit testing. I'm gonna take out this like hack together handler now. That looks right. The like lines handler. Yeah, lines handler. The lines handler. Well, before we really say what that is, let's write some unit tests for it. So I'm gonna make a new package in Go just to hold this handler. And I'm gonna like do some basic initialization, make this thing called handlers, we'll make a file called lines, we're gonna go ginkgo bootstrap, this sets up some test stuff for the BDD testing framework we use. All right. So I've got this empty lines package, and then I've got a test file that doesn't have much in it. So the lines handler, what's a thing it does? What's the first spec we might write for a handler? Yeah. No, let me show you the file system. We've got handlers, which I just created. There's the main method, which is its own, it's like the server binary, and then the system test was running inside of its directory. Yeah, so in Go, like there's this trick, right, where you can put underscore test, and it's actually got two different packages in the same directory. Yeah, this is what we do. Underscore test, this is a nice trick that Go lets you do. No, yeah.
The purpose of it mostly is to force you to actually test it publicly at the end of the object that you create. Versus if you're testing the C package, you could easily test the private.
Yeah, so we're gonna write stuff that's like handlers dot, right? That makes sense?
Yeah, it makes sense. I'm just very confused by this feature.
Oh, okay. Yeah, it's a thing.
Question about your import sentence at the top there.
Yeah.
The import dot, is that done to preserve the scope between the test and regular?
It's done so that I don't have to say this gomega.describe and gomega.it, because I'm going to write a lot of describes and its, and it's a lot more fluent if I don't have to do that. There's, related to what Ryan was talking about, like there is a trick, and in fact if I undo back a little bit, you'll see by default the bootstrapping thing actually gives me a dot import of my own handlers code. We don't like to use that. That's just like, if I'm testing my code, I want to see the name of the package in front of the thing that I'm testing. So the first thing I always do is take that out.
And do you actually do tests inside your own package with private?
No, we don't test private methods. If it is worth testing, then it's worth being a public function. And if you think that kind of blows your mind, then yeah, like that's part of the motivation, I should say, for doing dependency injection, is that if it's worth testing, then maybe it's worth being on its own object that's separately unit tested, and you can mock that thing out. So we'll get to that in a minute.
If you're really interested in this, Andrew Yang has a talk called like testing hacks in Go. That's like enlightening, and like there's a lot of really cool stuff you can do with the testing packages. So if you're like interested in what you can do with this kind of stuff, you should check that out.
You put it on the GitHub?
Cool. All right, so like the first spec for this handler, I'm going to say like it responds with some JSON or something. Like the handler is going to do a couple things, right? It's going to parse out the URL and get the package that it needs to count the lines in, but it's also going to return some JSON. Let's start with the last thing. So it responds with JSON encoding the line count. So again, without this handler actually existing, I'm just going to write code as if it does. So the lines handler is going to be a handlers.lines. I'm going to assume that it's a Go HTTP handler, which means it has a serve HTTP method on it. So I'm going to call lines handler dot serve HTTP and pass it in a response writer and a request. And then, and we'll figure out what those are in a second. We're going to expect that the response code equals 200 again. And then we're going to do something similar to what we saw in the system test. We're going to read out the response body. So response bytes. We'll read that out of the response body. We're going to expect that that didn't fail. And then we're going to make an assertion about those response bytes. We've got these cool matchers in GoMega, match JSON, and this is going to look like what we had in the system test. All right, so the vim config shows me a bunch of compiler errors. The first one is that this type doesn't exist, so let's go make that type, right? Hop over to this file. There's a type, and it's called lines. It's a struct, and it's got nothing on it. All right, hop back over to the test. And now it's missing a serve HTTP method. You can read along at the very bottom, lines handler serve HTTP undefined. So let's go write that method. And we're not going to have it doing anything at all right now. Need that R. Yep, response writer, thank you. Cool. Go back over the test, save it, watch the compiler do its thing. Now resp and rec are not defined. So who knows what those things should be if we're writing a unit test of an HTTP handler. What's resp supposed to be? HTTP test dot new recorder. This makes up a thing which is a response writer, but it also records everything that comes through. So we can write responses or write assertions about this response. That's where this this code comes from. And then the request is going to be an HTTP new request, and it's going to be a GET request. And it actually doesn't matter what we pass in right now. And there's going to be a nil. Yeah, what's the question back there? Because I've got some quotes inside of it, and I don't want to have to escape them. Yep. Go has this nice thing where backticks give you that. Otherwise, you have to do the C thing. So this looks like it's compiling. Let's try to run the test. All right, unexpected end of JSON input. Our handler doesn't do anything at all right now. So we'll go in here. And we do, this should look familiar, resp.write some bytes. We can do fumpt.sprintf. We're going to do this backticks thing again. Lines, and then I don't know what the lines are yet. I'm just going to make this get a little bit better. Run the test again. Okay. Now we have a meaningful thing, which is we're handling back nonsense, and we need to know what the real line count is. This is a place where we have a dependency. We have a dependency on some business object that's actually doing the work of counting the lines, and that's not the responsibility of an HTTP handler. An HTTP handler should speak HTTP, shouldn't have to know anything about counting lines. So what do we do here? This is where we would actually add a dependency to this type of lines. And this is kind of like the crux of the ideas here. So we're going to make a dependency. It's going to be called a counter. And then the question is, what should the type of this thing be? If I were to make a real counter type, which is a struct in some other package that implements things, I could just make this thing be the type of the real counter implementation. But I'd like to unit test this handler, and I'd like to unit test it by having a mock counter, where I don't have to have a real thing that's actually touching the file system. I'd like to be able to assert that this counter was called in a certain way, that if it's responding with a certain type of data, that the handler does a certain thing with it. I can do that only if I'm able to put a mock in here, which means that the type of this counter, the type of this dependency needs to be an interface. So I'm going to call this a counter interface. When we were writing code for CloudFoundry, we wouldn't normally put the interface suffix on there, but I think it's a little clearer. And so this type is going to be interface type. And it needs to have something on it. It needs to have like a count method on it. And the count method is going to be really simple, right? It's going to take like a package path, which is a string, and it's going to hand back a line count as an integer and maybe an error. And with this dependency injection stuff here, now we can go back to the test and we can start to figure out what goes in here, right? Because this handler now needs this mock injected inside of it. So the counter is, we want this to be like a mock counter. And what I'd really like to be able to do is, in this test, have the mock counter respond with the line count, right? So let's imagine we can say mock counter dot count call, that count call returns a line count, and that's equal to 42. And if I could write this line of code, then it would make perfect sense for me to make an assertion at the bottom assertion, down all the way down here, that the line count is 42. Does everyone follow that? Okay, so now we're just going to have to actually implement this mock. This might be the least interesting part of the talk because I'm going to handwrite a mock. But one of the advantages of handwriting the mocks is that you get this kind of fluent syntax when you're actually using it in the test. So let's go ahead and do that. What would you test on the interface? Oh, but the type system gives me that, right? The compiler asserts that the only things that will match that interface are things that match that interface. Maybe I'm misunderstanding the question.
I mean, that's fair, but you have a line count and, oh, I'm good. Go ahead.
Okay, cool. I'll keep going and maybe we can see if it addresses your question. So I'm going to make like a directory just for my mocks. And I'm going to go in here and I'm going to make a new file, package mocks. And this is going to be a mock line counter. So before I leave this, I'm going to copy this line of code, this function definition, because we're going to implement a mock of it right now. So we want this thing, we want this function, and it's going to be a function on my mock. And I'm not sure exactly what's going to be in here yet, but I know that when I looked back at the tests, right, that I had this fluent thing, mock counter.countCall.returns.line count. Let's make that real. Oops, wrong file. So this is going to be a type, and it's going to be a counter, and it's going to have an embedded type in it, which is the count call. And inside that, it's going to be another embedded type, which is what it receives. And that's going to be the package path, which is a string. And then it's going to have what it returns. And that's a line count, which is an integer, and there. So we've got these anonymous structs embedded inside of other anonymous structs. And then it lets us write the mock method in a pretty straightforward way, right? The first thing that it does is that m.countCall.receives.packagePath is going to be the argument that was passed in, right? And then the next thing is it just needs to return the two types that are on the struct. So it returns m.countCall.returns line count and m.countCall.returns.error. Does this make sense? Cool. So now we can go back over to this test, recompile, and let's see what happens. Undefined mock counter, we should make that thing. Mock counter is going to be a new instance of that type we just made. Mocks dot, what did I call it? Counter? Pointer to, yes. Very important that it be a pointer to, otherwise it does not remember the fields, what's set on the fields. Okay, and then that fixed up all the compilation errors. So let's try to run this test. Gotta hop back over to handlers. Okay, same failure as before, and that makes sense. We've just done a bunch of work in test setup so that we can enable the real production code to actually work the way we want it to, right? So now,
Gabe,
yes.
I have a question. Why did you make it so long for the mock? Like you have this mock count dot count call dot returns dot line count.
So let me try to answer it like in order of the different dots. So the first dot is count call. If this mock were to have more than one method on it, I would want to be able to distinguish between the calls to the count method versus the other method. So that's why this section needs to be here. Returns is there so that I can distinguish between what it returns and what it receives. And then obviously the values that it returns, if it returns more than one value, then I need to have names for each of those.
Use this approach for every single mock you write?
No. I should say the team that I was on 6 months ago, we did this pretty religiously. Every single mock that we had to write, we hand wrote it in the style above, the style that you see here. And like, one of the things that becomes a little bit painful there is that if you want to count how many times this method was called, or if you want to record not just the first time that it was called or the last time that it was called, but every single call to the mock, you have to do a little bit more magic in here, right? Maybe make up an array or a map or something and record every call. So the logic becomes a little heavier weight, but it gives us this fluent test description, right? Like, I just love the way that this reads, because I can say this and I know exactly what this mock is supposed to be doing. Now, the team I'm on right now, we tend not to use this style. We actually automatically generate the mock from the interface. There's different tools out there. At the last meetup, Evan Phoenix showed off one of the things he wrote that does this. I'm going to show you that in a little bit later, auto-generated mock, because it has some advantages. Good question, though. Okay, so let's go like implement this thing for real. As far as this handler is concerned, it's got a counter that it can call. It doesn't really care whether it's the mock or the real thing, and so we can just call that thing, right? l.counter.count, and then the package path, we got to get that somehow, and that's gonna return lines, and it returns an error, but we'll ignore that for now. Package path, we don't really know what that is yet, but I'm gonna say, like, for this test, it doesn't actually matter, right? This test isn't covering where the package path comes from. So I'm just going to say this is something. And then this lines, this is the meat of what the test is covering. So let's put that in there and then go like that. Is it going to pass? Yes, it's going to pass. I better pass. Passed. Cool. Okay. So let's go back and write another spec. What's the next spec we might write? Different number? Okay, what's that going to cover? Like, why would I write one about a different number? I want something that like forces me to not have my package path be the word something. It should be like, that should be the real thing, right? So I want a test that forces me to parse this package path out of the URL on the request that's coming in. So let's start with that, or go to that next. So it interprets. We can be really like fancy with our English in these descriptions. It interprets the URL path as a package. And so setting up this test is going to look a lot like, but not exactly like the previous one. So we're going to still have a lines handler. And it's still going to have a counter, which is the mocked out thing. And so we'll need to go make another mock. And we're still going to record the requests and the response. But then at the end of this, the assertion we make is going to be different, right? Up on line 32, the assertion was about the response that came back. At this point, we want to actually make an assertion about how the handler mock itself was called. We want to make sure that it was called with the right thing, right? And so at this point, the request that we pass in can't just be a / whatever. It needs to be the URL path that we expect this thing to actually handle. So that's going to be /line / a real go package. And then down at the bottom, after this handler has actually done its work, at this point, I want to make an expectation that the mock counter dot count call dot receives dot package path. That thing should equal, what do we have it as? A real go package. I'm testing that this route was parsed out by the handler, and that the important part of it was taken and passed into the counter, right? So I'm making sure that the counter isn't just being called with garbage; it's being called with the right thing. I don't think that's. I mean, it's testing the internals of the code under test, which is what I want to do, right? I want to test that the code under test does the right thing, which includes that it calls its dependencies correctly, that it doesn't forget to set a particular value on an argument that when it calls a function, that sort of thing. This, you'd think that this is pedantic, but this catches real errors. Like, you have some variable, you created it up top, you forgot to initialize it to the right thing, and now your dependency is not being called with the right arguments. So we've got this, what is it? It doesn't know what a lines handler is because I mistyped this. And now error is declared not used, that's for sure. We're gonna just ignore that. I'm probably doing that up here, aren't I? Nah, screw that. We don't care about that. This is an error in test code. No, I'm imagining that the way this handler works is you go to like the server /lines/ the name of your package, and then that package is the thing that it goes into the counter. So this /lines is actually here to. Yeah, it's like this is. Well, it's going to actually be cut off by the handler, but this is like part of the path that this is the API of the service is /lines/ the thing. Okay, let's run this test, see what happens. By the way, how am I doing on time? Oh, wow. It's having half an hour? Okay. Okay, so it got something, and we're supposed to be getting the real Go package, right? So let's go make that real now. One of the things you'll find with this approach is that writing the test is often a lot longer than writing the production code. Yeah. Yes, if you want to, you can do all sorts of crazy stuff. In fact, the system test, at the end I can show you how the system test is written. There's a little bit of magic that I didn't show you, which includes spinning up the server before it gets to the spec and then tearing it down at the end. And there's all sorts of crazy permutations where you can spin it up before every spec or before the suite. It's cool stuff like that. So this package path, the naive thing here would be request.url.path. But this is, when you asked about lines before, that's going to be the problem here, right? So now it's getting /line/ a real Go package, and it really needs just a real Go package. So we're going to have to trim that. And again, the naive thing to do would be strings.trim prefix, and then this thing, and then /lines. Cool. Okay, green. There's really just one last test that we need to write here. What is it? There's one thing that needs to be tested about this method that we haven't done yet. Error, yes. You have a question, yeah? If it's put on, so like if it gets in a request that doesn't start with /lines, yeah, this trim prefix will just, the way the trim prefix works is it just ignores the thing that's not there, and you'll have some interesting behavior. You could say that maybe this thing should fail if it gets a route that doesn't begin with /lines. You might say that's the responsibility of the muxer or the thing that's higher level in the program. It's a good question. In this toy example, I'm not really care, but I think in production code we'd like think about that and what's the right thing to do. Okay, so the real thing here is that there's an error that's missing that we're not tested. And I sort of tricked you because when we write this way at Pivotal, we don't use underscore to ignore the error. We always say error, and then if error is not nil, the first thing we do is just panic on it, which just crashes the whole damn program, right? We write the panics in there because we are trained to know that they're not supposed to be there, so that when we look through the code before we actually commit it, push it up to GitHub, we see a panic in the diff, and we're like, well, okay, we've missed something because there's still a panic in the production code. So this is basically the same thing as writing /to do handle this error, right? And so when I see this in the code, I'm like, okay, I still have a spec to write. So let's go write that spec. That spec, now we get to use in one of the fancy BDD things, context, when the counter fails. What does it do? What should this thing do when the counter fails? 500, great, yeah. Like, if you knew that it was because the user asked for like a package path that didn't exist and you wanted to tell them that thing doesn't exist, maybe you return a 404, but for now, let's just say it's a 500. We can worry about like discriminating between errors later. So it responds with a 500 status code. All right, this test setup is going to be remarkably similar to what we've seen before. We make a mock, we inject it into the handler, we make the request, we serve it. We have to do two more things. Expect that the response code actually equals 500. And then we need to make our mock do the thing that it's supposed to do, which is respond with an error. So this is going to look like what we had up top, this line. Except now the returns error is going to be banana. That's the official pivotal mock error, is banana. Okay, so there's a spec. Let's run the test. Oh my god, that's a big stack trace. Test panicked, banana. Let's go fix that. This is the easiest, most fun fix ever. If there's an error, we're going to say resp.write header. Not sure why it's called write header, but you write header 500, and then you return, and you don't panic. Ta-da! 3 unit tests, green. That's it for the live coding. I'm going to go back to slides in a second. No documentation. Like, no, we of course not. We don't write documentation. No. If you're asking, do we put comments inside of our code? The answer is not very often. Yeah, the Go docs. Yeah, like we find that if the code is only going to be consumed by people internally, like our team, these specs are better than any comments, right? Because comments go out of date, but if specs go out of date, your continuous integration system fails and you see an error. So
you're not describing the interface, you're not documenting the interface. You're not talking about the mocks, you're talking about the interface.
The interface, yeah, generally we do not do that. Like I would not necessarily write count and then like this counts the lines, right? Or actually, what would the Godoc style would be count returns the number of lines in the Go source. No, we don't do that generally. I think that, but I should say that we don't do that. But I've only been on teams that have written code that it's like application code that's not meant to be library code that's consumed by other teams. There are definitely parts of CloudFoundry that are reused. For example, we have a logging library that we like to use, and the testing frameworks, obviously, like the actual Ginkgo and Gomega testing frameworks we use, those have Godocs for sure because people expect to use those. So I would say like you put Godocs on things you expect other teams to make use of.
So if you use internal code, you have to go and read all the tests every time to understand how it works?
I haven't found that to be a problem, but I've also only worked on relatively small code bases. One of the things I didn't say at the beginning is I've worked at Pivotal for like a little more than a year. I don't have a lot of experience on this Go stuff. Some of the people on the team certainly have more, but I can't speak to a lot of this based on like depth of knowledge of doing this for a long time. I'm basically showing you this is the way we do it here, and it's worked out pretty well. And we adjust as we go. But I couldn't tell you like I haven't been on a team where we've had to write Go docs, but I may be on one of those teams someday. Yeah.
Is there a specific reason why your interface type is unexported?
That's a great question. Let's park that and come back to that at the end of the talk. Totally. This is the mock. You have a question about it, or? Oh yeah, I actually did it at the beginning. I kind of slipped it in there without telling you, but the principle here is like, well, we've got this interface and it has this method signature on it, so just make sure that's the thing in the mock. If you screw up the mock and you like forget to put the error in, you're in a world of pain, because like you're trying to write tests and they're not failing in the right way, and it's because like your mock isn't returning the thing. So get this right, which is maybe it's an argument for auto-generating these things, by the way. Okay, cool. That's all it for the like I'm actually coding in front of you part of this. Yeah. So I'm going to get to that now. Exactly. So let's see here. What are we going to do? We've got all this code, and I'm just going to like blow it away. Yeah. It's on GitHub, and I'll put the link in. So what's on GitHub is like a list of commits, which I can actually show you now. All this stuff. So basically, we started down here at start, and what we just went through in the last few minutes was like first system test passes. That's weird. First unit test of the handler. Where we basically got to this point, and then what I'm going to show you now is I'm going to fast forward all the way up to the top, and I'm going to show you what the whole thing looks like, and then you can sort of go through this kind of exercise at your own pace. Yeah, so it's up there literally at this URL, github.com Rosenhouse counter demo. So yeah. Not for this code base. I'm not going to write any documentation for it. Yeah, the system tests the real implementation, right? So when everything's assembled together. So let's look at that now. Yeah, and this is a really interesting topic about like what points do you mock and what points do you use the real thing. And I'm actually going to get to that in a little bit, because like there are these other types of tests where you want to like test the way that external systems are being accessed, and you don't want to mock that out because then you're not actually capturing the behavior of the real system. Okay, so now I'm going to blow this away, all right? Okay, git checkout dot git clean dot xdf. Okay, back to that, and then I'm just going to check out master. Cool. So now we can hop over here and like everything is changed. Let's see, what do we have inside of mocks? There's the mock we just wrote. It's pretty much unchanged. Let me show you that the system test passes. In fact, let me show you that all the tests pass. Okay, so we've got a bunch of unit tests about counters and handlers, and then the system test passes. That's awesome. So we already saw the tests of the handler. Should be basically the same. Yeah, that's all the same, but the thing we mocked out was the counter, right? So let's go look at what the real counter looks like now. So the real counter is in this package called counters, and there's a package counter, and the package counter, it's this type here, line 19. Excuse me. It has a configuration variable, the go path that it's going to look in, and it has two dependencies, the directory lister and the file lists counter. And if you just look at what the real code is doing, this totally makes sense. It checks that the path is clean, that you're not like trying to go .. and to escape outside of the path. And then it lists all the files in the directory. And then once it gets that file list, it just iterates over the files and counts the number of lines in each file and adds them up and then returns that, right? So this is the real code. It's got two dependencies. It's got a directory lister that it uses, and it's got a file lines counter that it uses. And each of those things is accessed as an interface that is injected as a dependency into the real type. And so then the unit tests of this package line counter will mock out these two dependencies. Now, you'll notice there's this interesting looking line here. Who here has used Go generate before? Okay, yeah, this is kind of like an advanced feature of the Go ecosystem. It lets you write tools that write Go code, and then some of your source code you don't have to write yourself. Some of your source code is generated by the code generation tools. It lets you do stuff like go generate ... and it just wrote file lines counter to mocks file lines counter. So I didn't have to write that file. It was just created for me on the fly. That mock is it's great, but it's disgusting. Where is this thing? Okay, this file lines counter has a stub. It has a mutex. It has some other things. The mutex is actually kind of nice because you can hit this thing in parallel and it'll make sure it doesn't lose your data. It'll record every single call that you make to it. and you can also stub it out. And so let's look at how we're like using this thing. This was being used on the let's see, the package counter test is using this mock. So the way this test is set up, it's creating these two mocks. It's injecting the mocks into the real type, the package lines counter. On the directory lister, it's saying this thing should return these files. This looks exactly like the mock we wrote before, how we used it, right? It's got this fluent mock directory lister list files call returns these files. But then on the file lines counter, this is the function that's being called repeatedly inside that for loop, right? This thing, it's just being stubbed out, and the stub says, is this the first call? Okay, it's a 10-line file. Is this the second call? It's a 20-line file, right? And so then the test of this thing is saying, I expect the total to be 10 plus 20 plus 30. This is an example, kind of a nice one, where making use of this auto-generated thing, it's kind of nice to be able to write a test like this, where we just stub out the mock. We don't have to keep track of the multiple calls ourselves. Otherwise, the unit tests are kind of like what you'd expect. We've got covering some error cases, like someone's trying to get your password file through your web server, stuff like that. And yeah, that's sort of like, yes?
Which parts, it's not clear to me which parts are like pivotal convention and which parts are kind of from that.
Oh man. This is, so let's see here. Yeah, so like, the counterfeiter was written by a guy at GitHub, but all of the recent pull requests, oh, did he? Okay. Okay, yeah. So counterfeiter was written by a pivot, I guess. Ginkgo and Gomega were both written by ONC, who's a pivot. And yeah, this style is like, this is our style. I should say like Kubernetes uses Ginkgo and Gomega. It's not just like this in-house thing no one else uses. We can get into a discussion later about like why this is great. Yeah.
What's the downside of using the counterfeiter? You mentioned.
So yeah, that's a good question. I actually didn't use it in the ways that I don't like here. But the downside is, so I guess the upside of using the handwritten mocks is that I like how they read. I like that I can see the list files called .receives.dirpath. If I were to write this with counterfeiter style, it would be something like mock directory lister dot list files args for call 0 dot, what is it? I don't even remember what it's like. It becomes a little grosser. Like I think it would be dirpath. Yeah, I think it would look like this. This is how I would get to this argument that was passed in, and then I would write the expectation about the dir path. And it's basically that the tests don't read as cleanly. That's the short answer. It also, Brian doesn't like it because it adds a bunch of extra methods to your mock object, methods that are not on the interface that you're actually mocking out. And so it makes this object just in some ways heavier weight than the thing you're trying to test.
Is there some type coercion that prevents you from using mock directory lister dot inside of the expect argument?
Type coercion that prevents me from doing what?
I mean, you said you had to assign it to dir path. I didn't understand why.
You can do it, right?
Oh yeah,
If there's a single argument.
if there's a single argument. But if this thing took, like, if it took a dir path and a count, then I wouldn't be able to pass. So like in Go, you can't have a tuple that's returned by a function be the two different arguments that are passed into the next function. This isn't actually a very good example of why it's gross. I could pull up another one. But yeah, I'd say the advantages of using the auto-generated thing are really great. The team I'm on right now, it's a huge system. We've got lots of components, lots of interfaces, and so when we run go generate ... we get like 20 files that are all created by that mocker, and that's valuable to not have to handwrite those things. Especially as interfaces change, as we're hacking on the code, we're changing with the interfaces. We don't have to go change the mocks all the time.
Have you looked at any other Go test frameworks or anything personally and compared them?
I wish I had. I know that last time Evan Phoenix was talking about his mock generator thing, which I haven't really got a chance to look at. We've definitely like interacted with open source projects that you have their own ways of testing things. Clearly, the standard library for Go includes a testing framework, and all the standard library is tested with that testing framework, and it's just really simple, like XUnit style test some long camel case string. Back before I started at Pivotal, I certainly wrote tests in those styles. But not in Go. Yeah, that's actually a good point. So I can just go test, this thing? Yeah. and under the hood, it just runs everything. Yeah.
Show the suite test.
The what?
Suite, like when you say Ginkgo Bootstrap, the file it generates.
Oh yeah, right. That's worth showing. Totally. Okay, so like when I ran Ginkgo Bootstrap at the beginning, I kind of hid this because it's not very interesting, but it generates a Go test. This is what Go test consumes, right? Go test looks at something like this with a T, testing.t, and so all that Ginkgo is doing, and this is my own stuff. Ginkgo auto-generates these two lines, and so this run specs is Ginkgo's test runner inside of the thing. All right, that's it for like looking at me typing in Vim and everything. We're going to move on to some more slides now, unless there are questions. Cool. Okay, so that was the toy web server. Now I'm going to talk about like even if you don't TDD, like think about how other people are using your source code, especially if you're doing open source work, you're making a library, you want other people to use it. There's certain things you can do in that regard. So let me walk you through a scenario that's come up in real life on our team. We have a program. This is my program, and inside of it, it needs to make use of a third-party client to go talk to a third-party server. This is an RPC client and server. So we've got this RPC client object, and it's going to make a connection over the network. And there's this sort of RPC API boundary. And in production, in the real thing, there's going to be this big like server component, and it has an RPC like listener. And so our RPC client is going to talk to this listener. Wow, that arrow doesn't come through. And then inside the server, there's like some like logic, some important things, and this logic goes and talks to a database. And it actually goes and talks to a bunch of other virtual machines on the network. And so in production, our code is actually controlling all this other heavyweight stuff on the other side. Now, we want to write a test of our program, and we want this test to run quickly, and we want it to be isolated. So we'd really like to be able to run this test of this program without having the real server and the real VMs and the real database connected to it. So what would be super awesome is if I could have a fake server which has, it's a binary, it's running, and inside of it is the real RPC client. Because this RPC language we didn't write it. It's not HTTP. Sorry, yes, good, thank you. The RPC listener. And this RPC listener would then be backed not by the real logic of the server, but would be backed by some fake logic. And then I'd really like to be able to write a test that feeds some inputs into my program, including telling it to point not at the real thing, but point at the fake thing, point at the RPC listener and the fake thing, have it make the connection to the real RPC listener, talk to the fake thing, and to then make assertions about the fake data that came through and how this program responded. So then I can integration test this program without needing to have the real stuff behind it. So that would be really great if I could do that. But that all depends on this RPC listener, the way that it is constructed, right? When I construct this RPC listener, I'm injecting into it a dependency on some other object. And that other object is, in the real case, it's the real business logic, some concrete type that's in the source code repo for this other thing. And in the fake case, the injected dependency should be my fake, my mock thing. So the only way that's going to work is if that thing is consumed as an interface, right? So in code, what I just drew for you is, in my test harness, my third-party RPC server, it should consume a mock backend. I'm going to start it up, and then I'm going to launch my program and target it at the RPC server. And I'm going to run my program, and at the very end, I'm going to expect my mock backend, some particular function call on it, got called. We can do all sorts of crazy stuff. We can have this mock respond with certain types of fake data, assert that our program responds in the correct way. But this all hinges on my ability to be able to pass in a mock backend in here, which hinges on this constructor, which we don't control, consuming its arguments as interfaces, that each of the arguments of those things is defined as an interface type. If you don't do this, it's really hard for us to use your code. We have to, in this particular case, we actually had to fork the third-party repo, add the interface to it, and then consume the fork. So this is an example of like being a good citizen. Please consume your interfaces, or consume your dependencies interfaces, and makes it way easier for those of us who do use mocks. Yeah, that's all I've got. So questions, discussion would be great. Yeah.
Interfaces are slower. Has that been a problem?
Performance of interfaces has never been a thing that we've cared about. We don't necessarily write code that's bound by CPU, though. Most of the stuff we do on CloudFoundry is network bound. Yeah. So we were just showing a little bit of this. I just used it. Where is it? There you go. Go test dot slash dot dot dot. That actually runs the Ginkgo specs under the hood. So I think this is a positive answer to your question. But yes, absolutely. And then one of the nice things about Ginkgo, it adds a bunch of features on top of that. So things we like to do in our CI pipelines, in our testing suites, randomize all specs, randomize all suites, run the tests in random order. Race detector, switch that on. That's part of the standard Go testing. Let's see here. Parallel testing, where is that? P. Run your tests in parallel. Not only do they go faster, but it surfaces race conditions that you might not otherwise detect. Stream is used for streaming the output when you're running the tests in parallel. Kind of a crazy thing. And there's some other really cool stuff with Ginkgo. Like it has IO writers and IO writers that are hooked up so that you can pass those in as arguments to methods that use IO writers, and then when those methods run, the output's captured both to your test runner output, but they're also available to you to make assertions about the output from those programs. Yeah. That's correct. I didn't know that. Okay, yeah, this thing you can set, where is the n, the number of nodes that you're running, right? Cool, yeah.
So in your example, you said that you had to fork a library that you used.
Yeah.
And actually rewrote the constructor function signature to accept an interface.
Yes.
So that seems a little extreme. So do you have any ideas on how you can get around that through writing some custom classes in your own code base so you don't have to fork an existing repo?
Sorry, can you say it again?
So say you don't want to fork an existing repo, but you want to sort of rewrite how this constructor works within your own package. Do you have any ideas on how to do that?
You'd have to like wrap it, right? You'd have to encapsulate that object with something that does take an interface. Actually, even that wouldn't work. That would just still, yeah.
Because if it accepts a struct type, that is unless you modify that thing in place, which means modifying on the back end.
Right.
Which kind of
Exactly.
then that's the only thing it can accept.
Right. Because static typing. That's the short answer.
Right, like interfaces are more open rather than structured. So like you can only go in one direction. You can become more specific about the type, but like you can't become less specific.
Right.
What do you mock and what you don't mock?
Yeah, okay, this is right. And so like the thing that always comes to my mind is when you're interacting with external services, then you don't trust those external services to behave in the way that you specify. They're going to behave in their own way, right? So people call this enemy testing sometimes. You assume that the other thing is an enemy, it's going to do crazy things, and you need to write a whole set of tests that just sort of act defensively and carve out the shape of what you expect that other thing to act as. And so these would, like, an example that I'm really familiar with is Amazon Web Services. They have a bunch of different APIs. The error cases for those APIs are not always documented, but if you want to write code that relies on those errors, you have to do you basically want to write tests that verify that AWS acts the way that it does today, that it's going to continue acting that way tomorrow. So if you try to upload a new server certificate to AWS and something else with the same name is already present, Amazon gives you back a particular error code. And if you want to act differently depending on that, you need to write a test that actually uploads a real certificate to Amazon and then uploads the same certificate or a different certificate with the same name and like checks what that behavior is. And I've done that, and I think it's necessary to kind of like isolate the craziness in third-party packages and give you a clean set of specs. One thing that would be cool, and I've played with a little bit, is having like a single place where you're both enemy testing the third-party thing and you're also generating specs or you're generating mocks for tests of your own code, right? Because there's this API boundary between the third party and your code, and if you have one place where you can define how that interface works, you can use that to both control or enemy test the other thing and also generate fake data to do integration testing of your service without hitting that third-party service. Yeah. But only after it's passed those tests. Yeah.
You're mocking out a third-party service, but then you have a test that makes sure that the service acts the same way your mock does.
Exactly. Yes.
Obviously, if it changes, you can't go to Amazon and be like, no, you need to change that.
Right. But at least you have detection of it, right? Like,
So that you can change your
exactly. Right. And so if you do that by hand in two different places, there's always a danger that like one of those things gets out of sync with the other one, right? But yeah, that's exactly what I'm talking about.
Would you mock database and data stores?
Okay. Another good question. We hit this today. So we are interacting with Postgres. We've got a client that talks to Postgres. And we want to do certain things when we ask for a record that's not there. When you ask for a record that's not there, you do a select unique or select one or whatever it is, and it says the record's not there. Postgres gives you back a particular string and says this is the error you got. So we need to write some tests of our client that hit a real Postgres server and make sure that our client like does the right thing when the record's not there. At the same time, there are error cases that Postgres might spit back that we couldn't generate normally in a test scenario, right? The database connection fails or something else crazy happens, and I want to be able to verify that my client is robust against those errors as well. So in that case, the client, the testing of that database client actually needs to use two different backends. The first one is a real one, and it also needs to run tests against a mock. And if we use the mock, we can have the mock generate all sorts of crazy data and see how our client behaves. And then we can have the real one there to basically do enemy testing. The real one is there so we can verify that it behaves in the way that our code expects it to behave. That was kind of crazy that we encountered that today, but it just seems completely natural in retrospect. And I've since learned that we did this on other code bases on the team. Yeah. Other questions?
What do you think about table tests?
I love them. I started using them about like a few months ago.
You guys don't seem to.
We don't use them. They were added recently to Gomega, and I've since started using them a lot for doing like stuff like you've got a CLI program and it needs to handle like errors like you missed a flag that's required or something, right? And so like table tests are great. Like you're missing this flag, do this. You're missing this flag, do that. It's the same kind of behavior over and over again.
What?
Table tests?
Yeah.
Oh, okay. Let's talk about table tests.
Open the Golang test suite, the code.
Just like, do you have a particular file?
That's how Go is being tested.
Yeah, I don't know if I can go straight to a file. Let me see if I can pull up. Let me. I'm going to pull one up from code that we've actually written, like in the last week.
You're basically defining this input, output, and you basically create a struct for all the stuff, and then you can have a description on that.
Describe table flag errors. This is what I was talking about. So you're missing listen adder, and you're missing overlay network adder, and you're missing these things. And each one of these rows are just like simple specs. The only difference is this like a few arguments, but then the same function is being run every single time. This is, you can do a little bit of prefactoring, right? Like if you think all your test cases are the same and then you refactor to a table test, and then it turns out you've got another test case that doesn't quite fit, that can be a little annoying, but that's just a general thing that happens when you refactor too early, right?
One more question.
Yeah.
How do you feel about you guys going in a totally different style than the Go team and the way Google usually writes tests on the product?
Go is not a Google product. Go is a, like, right? It's the different people have different styles. I don't think like they are the end of like, that's not the end of the story right there. Like I said, Kubernetes uses it, other projects use it. I think there's some advantages to the way that we work at Pivotal that maybe feed into this style, right? Like we pair program, we test drive. Those things are really optimized for the particular way that we organize teams and the type of people that we hire and the type of work we do. And I wouldn't claim that it's of all that stuff.
I mean, for instance, when you have a project like that and I want to contribute, I don't know your library.
Right.
It's a learning curve, so that's a con.
Totally.
On the pros, I'm not sure. It's pretty, I guess.
It's easier to read, don't you think? Don't you think you could look?
It's easy to read, especially with all the context and the scopes that get nested with all this function. I actually find it very hard to read.
Okay.
But
So,
maybe also being used to it, you know where to jump to exactly.
well,
Like, it's not that
yeah.
far out of line with like a lot of other testing frameworks that exist in other languages. Like if I came to you and said, this is a BDD style testing framework, you could easily pick that up and say, okay, I've used Jasmine in JavaScript, or I've used Node in Python, or I've used RSpec in Ruby, and like the same concepts apply across all of those frameworks. So like for us to say like, oh, okay, there's a BDD style framework in Go, isn't that far out of the box because there's a whole host of other languages that support that style. I think that there's a huge audience for that.
I really think it makes the test easier to read, especially for people who are just coming to a project. They're trying to understand at a high level, like, what is this thing doing? Reading English descriptions of it that are kept up to date by CI, it's pretty great. I'm curious, like, have you worked in this with BDD style before and like decided you don't, like, you're moving away from it? Yeah. So why did you move away from it?
Well, I mean, so it's different context because I was one of the first RSpec users in Ruby, and I think that the way we were writing tests in Ruby made a lot of sense. And as I moved, after many years of experience, I found out first nobody's reading these tests. Like nobody's reading the English. The idea was first we're going to write English tests and we're going to convert them. That's not true. Like nobody's really reading them. Only developers are reading them. And a lot of time, you end up spending a lot of time doing all this ceremony around this one specific test that in a table test you would do much faster.
Well, I feel like you're setting up maybe a false dichotomy because you can always refactor and extract common test setup into a before each that's run before every single spec.
And then now you have a really hard context with photo and you have bugs. So when I started with Go, one of the things that we tried was to use, it was not Go Mega, it was another one, but forgot the name, but same concept.
Sure.
Less setup you have to do. Which one? No, it's not Golang. It was one before that. Anyway, it doesn't really matter. Same concept. The problem we had is we had bugs in our tests, and they were actually due to the test suite and the way we're using it. Because if you look at it, you basically have closures. Everything is a closure. You're passing a function in a function in a function.
Yeah.
And then the context gets set somewhere else, and you don't know where it's being set. And then now you have bugs in your test, and you have no idea where they come from.
Yeah, I think it's important to keep the test setup as close to the spec as possible. I don't like it when there's like a bunch of magic that's happening in a completely different file from where the spec is being written. I don't think so. It depends on how you use it. It's a tool, right? Yeah.
You can totally write a top level describe and then just have it all the way down, and like no repetition of setup, no repetition of tear down, none of that, and like it's functionally equivalent to your test, your actual like XUnit test. So you can totally write that kind of like style.
Then why adding a dependency on a different library if you could do the same way with the built-in library?
Because they like the way it looks.
We actually don't find that we have issues.
Well, yeah, and I would say, like, you say that people don't read the test code. We read the test code, right? The English, yeah, like, we read the English descriptions, right? Like, that's the first thing that I do when I see a new project. If I'm rolling onto a new team and I'm working with a pair and we're working on something, like, I'm going to read those specs.
Having worked with BDD before,
Yeah.
you say read the English, but what if you just
Yeah, you could totally comment, right? One of the advantages of doing it like this is that when the tests run, if there's a failure, these strings get printed out, right? So I can see this chain.
In a table test, you do the same thing by having a description.
Yeah,
Different ways of getting to the same point.
totally. Yeah,
What people seem to like with that, the BDD approach is the fact that it reads more like English. Do you like
yeah,
being able to
yeah. I mean, like, if this didn't say it, but this just said something else, I wouldn't be like heartbroken over that. I like the opportunity. I like the fact that there's this convention that forces me to write this. I'm curious, like, getting away from the BDD stuff specifically. I'm curious about people's use of mocks and dependency injection and interfaces. Like, is the way that I presented that handler being built, is that something that is familiar or foreign? Familiar? Okay. Cool.
depend when, how often you use mocks and how far you go. And for me, what you were doing by testing that the argument was being processed
Right.
inside,
Yeah, yeah.
it's too much. I think I would want to check the result. And that's why I like table tests when I put a bunch of input and I want to make sure the output is fine. In this specific case, I might have a feature folder for my system, which is called system folder.
Yeah.
We have a bunch of folders and it will actually test real code against that and verify that it's compliant with the code.
So I think that makes a lot of sense if there's just one code path straight through and you know that like the result of one function call is going to be fed into the next one. But I think when the logic inside the function becomes complex, when there's control flow, you've got if statements or for loops, and you're not sure that a particular function is always going to be called the same way, then it becomes exponentially harder to come up with test cases that cover every single path to that code. And I think that rather than having exponential explosion of test cases that are going into your table, it's really beneficial to isolate the complexity that's in that function call by having the mocks and just forcing yourself to drive through each of those code paths individually. That, like, when we do that, like I've found that when we take a test that was using a more functional type of unit test where we had a real thing behind it and we replaced that with call-based mocks like I showed you here, the number of test cases that we needed to write for dropped down usually by an order of magnitude. It would go down by a factor of 2 or 4 or 8 depending on how many code paths there were, if there were 1, 2, or 3 if statements, for example, inside of the function under test. And that's a huge win, I think.
The other challenge we found is using interfaces gives you another layer of abstraction.
Yeah,
So you get a lot of abstraction and it's hard to know, you don't get conclusional, you don't know what's going on.
totally, yeah,
You might get a disconnect.
right. And like the trade-off there, well, go ahead.
I know I was guilty of overusing interfaces.
Right. I think like what you're coming to there is just like maybe you're refactoring too early, and maybe you're putting in abstractions that don't need to be there. That doesn't really have to do with the language feature of interfaces. It's just you're refactoring too early. And on the plus side, if you make the right abstractions, then your code is modular. It's easy to swap out one backend component for another one. We did this today. We had a service before we wrote this Postgres client that I was just talking about. It was backed by an in-memory store. And everything worked, and then we decided we needed to go to Postgres. So we wrote one file that implemented the Postgres client and dropped it in instead of the other thing, and the interface didn't change. The tests of the higher level package didn't change. All the tests stayed green, and we just wrote run more unit, and everything worked. And like that's just fantastic when that happens.
The one thing we did really wrong when we talk about dependency injection is when we started the project, we put in dependency injection at the package level. So you can think of, for instance, you have a package that has a data store, and we would mock the data store. You have a way of injecting a different data store. So you can try MySQL, Postgres
In different packages?
at the package level.
Huh.
So the problem is it was a singleton, and the problem is when you have different tests running, you were injecting the dependency, but it was set as a package, and you couldn't run the test in parallel, and that was kind of a mistake. And the way you're showing it, I think, is a better approach, even though it's a bit more work. You're injecting onto the service itself what you need for each of the services. Does that make sense?
Yeah, I want to pull up the main method for this thing. Because I think that the way that it shows, the way the dependency injection looks at the very end, oh man, did I overwrite this?
Well, for instance, in our case, the mistake we made is we would
There we
have
go.
line count that would have like a counter type, and we would set it on the package itself. So
Yeah, right. So this thing I really wanted to show. I'm glad I thought about this. This is like the entirety of the dependency injection, right? And like, Your main method looks like this, right? You load in some environment variables, and then you create this big tree of dependencies, and then at the very end you just like launch something, right? And this is just declarative, and obviously if the directory lister needed to be reused, you'd make it outside of this and then reuse that variable in a couple different places. But you can imagine this type of tree growing and growing, and because every dependency is accessed via an interface, there's actually no inter-package dependencies at all, right? The lines counter actually doesn't even have a reference. Sorry, the handler doesn't even have a reference to the counters package anywhere inside of it. Except if you have some types that you're extracting. If you're using some structs, then that happens. But if you look at the sort of dependency graph, it goes from being a big spaghetti mess to being this like big wide tree with essentially one layer to it. Main injects all these other things. Yeah. Okay.
Is there a reason that you're choosing to do it as setting interfaces as members of that struct as opposed to on the struct itself?
Let me see. So you're talking about, well, let's go to a slightly more interesting one. So like right here, these two lines? Yeah. Okay, and you're asking about the difference between this and what's the alternative?
Well, I'm saying instead of say setting interfaces on directory listener and file lines counter, setting an interface on the package lines counter struct, and then passing that into the methods that where you would be using that.
Oh, I see. So it would be fed in as an argument to the method as opposed to being a field on the struct. Yeah, this is just to basically if you know the dependency is going to not change, then you can set it early on when the program boots, and you never have to pass it in as arguments. But a good counterexample, what you're talking about is logging. So if we have an HTTP handler and an incoming request comes in, and the first thing it does is it creates a GUID that's like, this is a request number, whatever, and now I want to log that particular GUID attached to the work that's associated with it throughout the whole chain, right? So I would like my my counter to receive that GUID, and I want the things that it calls to receive that GUID. So when I look through the logs, I can see this failure was attached to this request. In order to do that, I need to feed some additional data in, and that data is going to change every single time. Every single request that comes through is going to get a different request ID on it. And in that case, I'm going to actually pass like a logger object down through the whole call stack. And like the first argument to every single method is going to be, it takes a logger. And because that changes. And so in that case, that would be what you're talking about. Yeah. Any other questions? Cool. Thanks, guys.